Section 4.1 Related Rates. So we look at this problem, an inverted cylindrical cone. So as the figure shown, is 36 feet deep and 18 feet across at the top. Well, 18 across means 9 is the radius. Okay, it is being filled with water at a rate of 14 feet cubed per minute. Now, this variable, okay, what is given to us, we need to understand is the change in volume with respect to time. And you know it's volume because it's feet to the third power, right? And you know it's the time because it's over the minute, okay? So you need to be able to know the unit. Once you know the unit, you know what is given to you. So then the question is asking, at what rate is the water rising in the tank when the depth of the water is 1 feet? So the question is asking us to find, so what is the rate the water is rising? So dH over dt, because it's asking for rate, okay? It has to be something that's changing with respect to time. And when is when the water, the depth of the water equals 1 feet. So how do we use this information to solve the problem? We need to, and because the key word, okay, related rates, we have to relate the volume with the height. And we know how to relate it. It's a formula for the volume. Volume equals 1/3 pi r square times h. Pi r square is the base, area of the base, times the height. But because it's a cone, so it's just 1/3 of a cylinder. So this is what we all know, okay? That's all we know. Now the problem is, and again, another keyword is rate. That means we need to take derivative, okay? Rate is d over dt. We need to take the derivative with respect to time. The problem will happen right here is that, okay, we are given v, we are given h. We need to relay those two in order to find the answer. But how do we deal with r? Because we want to relate v and h. We don't want r to present. R is a radius. So what can we do? Again, you have to relate r with h. So let's say this is 1 feet deep. This is the r right here. So h and r. Okay. How do we relate those two variables? Well, if you take a look carefully, okay, what's going on right here? And again, we need to think about our knowledge between from pre-calculus, talking about similar triangle. Okay. Oh, sorry. Okay, so if the bigger triangle has 9 and 36 here, and the smaller triangle have r, okay. Smaller triangle has r and h here. How do we relate that? We use a ratio, okay? R compared to h is the same as 9 compared to 36. So then we just solve for r in terms of h. What happened right here is that if you multiply both sides by h, r will equals 9 over 36, 1/4 of h. Now in that case, we can replace r by this expression and have a relationship only between v and h. So what happened here? We will have v equals pi over 3 times h over 4 square times h. Now we simplify it, we get pi over 3 times 16. 3 times 16 is 48. Okay, times h squared times h is h cubed. Now we just take the derivative with respect to time. Okay, so what happened? dv over dt, okay, that's the derivative of volume with respect to time. Pi over 48 is a constant, so we just leave it alone. But when we take the derivative of h cubed with respect to time, we get 3h squared. Okay, that is the outer function. And the inner function is h, so we get dh over dt. And all this is because of the chain rule. And because h is a function of time, h change with respect to time. Now we should be all good to plug in the number. dv over dt is given, is 14. Pi over 48 times 3 times h squared, h at the time is 1, okay? dh over dt. Now we can solve dh over dt, okay? And you use a calculator. It's approximately, you can solve it exactly, but we just need an approximate. 71.3014 feet per minute.